A common task for biologists to work on a particular gene or protein is to find a set of orthologous protein sequences and create an alignment of them to identify organism-specific differences. An example of such a comparison focuses on the human ADAMTS8 protein, which is a potential tumor suppressor with reduced activity in many cancers. Whales, dolphins, porpoises, and other cetaceans, despite their vast size and long lifespans, have relatively low incidences of cancer, making an interesting comparison to the human protein. In this example, we'll start with the human ADAMTS8 protein, find a set of cetacean orthologs, align these sequences, and focus on amino acids that are common within cetaceans, but different from those of the human sequence. From the NCBI homepage, we'll do a search for human ADAMTS8. You'll note a helpful gene box at the top of the page with a button to the orthologs page. To collect the sequences for your alignment, first check the human sequence box and add it to your cart. To gather these cetacean sequences, you can use Search the Taxonomy tree and start typing whales, and click Whales and Dolphins Cetacea. At the time of this recording, there were 18 cetacean ADAMTS8 orthologs available. This number will likely increase over time. To add those 18 cetacean sequences to your cart, click the 0 selected box at the top of the table, which then changes to 18 selected, and then click the Add to Cart button. Now you can access those 19 items in your cart by clicking the cart symbol and set up your protein alignment by clicking that button. Please note that due to the presence of transcript variants, there may be multiple protein sequences translated for a particular gene. We'll stick with the one sequence per gene, and then click the Align button to send 19 representative human and cetacean protein sequences to a version of the BLAST algorithm called COBALT, the constraint-based multiple alignment tool for protein multiple alignments. To run the COBALT tool with these sequences, click Align. COBALT takes a short time to run and produces a results page with an interactive, graphical, multiple alignment viewer at the top, a table with information about the aligned sequences in the middle, and a text view of the alignments below. In the graphical viewer, let's zoom between about position 250 and 350 by clicking and dragging in the coordinates region. Then click the plus symbol to zoom in enough to see sequence. The human sequence is at the top, and you can see differences between human and the cetaceans, as well as among the cetaceans, including gaps, and a potentially important expansion of glutamic acid residues in several species. You often want to see how the sequences in the set compare to a single sequence. Let's do that by right-clicking on the human sequence and setting that as Anchor. And we'll change the display coloring to show differences. The middle of a TSP1 domain is roughly at position 554. We're now in that region. Notice that the lysine at position 554 in human is different but conserved in most of these cetaceans. Another residue in human, position 603, is similarly different and conserved. It is very close to a glycosylation site. If you want to see percent identity and other statistics with respect to the human anchor sequence, click the Rows button in the toolbar. And if you want to download the underlying FASTA alignment, click the Download button next to Rows and choose the desired file type. That's all for our example. The Ortholog resource was developed as part of the NIH Comparative Genomics Resource Project, or CGR. CGR aims to enhance access to ortholog data as part of its mission to facilitate reliable comparative genomics analyses for all eukaryotic organisms.